So now let's look at what happens when there's a number in the numerator of our exponent. So in that last video, we only had 1 in the numerator. So with that, we just had 1 underneath. But if a number shows up in the numerator, then that becomes an exponent on your value. And really, there's 2 forms that we can go with here. We can translate it to this form, or we can calculate the root first. So taking the nth root of x and then raising to the exponent. Just sometimes one form is easier to simplify than another, but should carry out the same thing. So for example, if we had x with an exponent of 2/3, so how this will change is the 2 is coming in as an exponent and the 3 is coming through as a root. So we would be taking the 3rd root of, and then our base with the exponent of 2. So that's where we see our x squared coming through. So visually, something I like to think about is that those 2 pieces kind of stick together. We have our base and exponent coming from the numerator. And then by dividing by 3 up there, that's going to set your radical. So let's practice in changing these forms and simplifying our values. So 8 to the 2/3, and sometimes our fractions show up like that in the numerator. If it helps to write it kind of more horizontally, that's fine too. But what should be happening is that 2 is going to be working as an exponent, or that 3 is going to come through as a root. So we can transform this in 2 ways, but following the form that was printed on your paper, this is going to be a cube root. And then we'll have 8 with an exponent of 2. So this is the same thing as the 3rd root of 64. So what we need to do is simplify underneath the radical first, and then we can evaluate this cube root of 64. Now you can use a calculator to help out if we need to, but we should find that that'll simplify to 4. But what we could have done here, going that other route that I was saying, is that we could have taken the cube root of just the base, 8, and then had the exponent on the outside. And this can be a bit easier to do without a calculator because the numbers will be smaller, but cube root of 8 is 2, and then we're squaring 2, and that would get you to the same answer that we got with the first version. All right, this next one, we have 9 to the 3/2. Again, I'm just going to make this note that that 3 is going to be an exponent and the 2 is going to tell us the type of root that we're taking. So this is going to be a square root, and then we're working with 9 cubed. So we can use a calculator to help us out, but that should be 729, and then the square root of 729 will simplify to 27. And what we could do here is you can plug it in to a calculator in the original form. We want to show some work here. Like it says, write each expression in radical form and then simplify. So we need to show our steps here. But to check your answer, what you could do is go to our calculator, do 9 to a power of 3/2, and there's the 27 that we're getting out. So you can check your answer there. With this case, we can't check our answer because it's a variable, so all we can do is just change this to the correct form. So that 7 is our exponent, and 9 is the type of root that we're taking. So we're taking a 9th root, so I'm going to have the 9th root, and then we have this base of y and an exponent of 7. And then there's nothing else to do with it. I would simplify further. If this exponent was larger, then I could simplify values outside of the radical, but it's kind of like we would need 9 of them in order to do that. So with this, it's stuck just like that. And our last one here, so we have 2x in parentheses, and then we're working with an exponent of 2 and a root of 5. So what we're going to be taking is a 5th root of, and then everything in the parentheses there's that 2x raised to an exponent of 2. So it's very important to bring those parentheses through, that this whole 2x is going under this radical, and similarly it's all going underneath that exponent. So how this would simplify is taking the fifth root, and we would have 2 squared, thinking that exponent's going to go to each piece here. So we'd have 2 squared, which is 4, and x squared. And then I would see if I could take the fifth root of either of those pieces, which we can't, so it would stay just like that. So with these, just be careful of translating between the two forms, and just keep in mind the numerator is going to come through as an exponent, denominator root.